Alright, today we're talking about finding probability of independent and dependent events. We're going to start with two definitions. The first definition that we have is independent events. Independent events. Independent events are events where the outcome of one does not affect the probability of the other. So independent events is when the events where the outcome of one does not affect the probability of the other. Our other definition is dependent events. Dependent events. A dependent event is where the outcome of one does affect the other. So it does not in terms of independent, and it does in terms of dependent. If we write this as a probability kind of equation, let's say we're talking about the probability of A and B. For independent events, it's just the probability of A happening times the probability of B happening. They do not affect each other. If we talk about it with dependent events, the probability of A and B happening, that's the probability of A happening times the probability of B happening. I'm going to put a little prime here because it's the probability of B happening given that A has already happened. Alright, so we'll talk about what this looks like in a little bit. So let's figure out, is this an independent event or a dependent event? So rolling a 6 on a number cube and rolling a 4 on another number cube. Well, if I roll a 6, the 4 has nothing to do with the first number cube. So these are independent events. Rolling a 6 on a number cube and a 4 on the same number cube. Well, my odds of rolling a 4 do not change based on the number that I rolled before it. So again, it's still an independent event. C, drawing a red marble out of a bag, keeping it out of the bag, then drawing a blue marble. Well, if I have one less marble in the bag when I go for the blue marble, that means the red marble did affect the probability of the blue marble, which means these are dependent events. A tree diagram. A tree diagram. I'm going to show you kind of how we figured this out. A coin is flipped twice. What is the probability of a coin landing on a heads both times? Well, we have a couple different things happening. We have our first flip, and then we have our second flip, and then we have our outcome. Alright? We're flipping two coins. Coin number 1, coin number 2, and then what's our outcome? So this is how we use a tree diagram. For a first flip, it could land either on heads or it could land on tails. So option number 1 is heads, option number 2 is tails. After we flip, let's say we land on heads. We flip another coin. We have two options. It could land on heads or it could land on tails. If it lands on heads, you can see that by my tree diagram, I have a heads, heads. So I'll write heads, heads. Here, if I heads, tails. So I'll write heads, tails. Let's do our tails flip. Let's say pretend I flipped the tails first. I have two options. It could land on heads or it could land on tails. So if I'm writing the outcome of tails, heads, or tails, tails. So that's kind of how the basic tree diagram works. If we had a third coin, I could then take each of these and I could write 2 going out as well. Alright, 2 going out from each spot if I had a third coin and was flipping it. So I want to know, what is the probability of the coin landing on heads both times? Well, that can happen one way. So my numerator is 1. And I have 4 different possibilities. So my denominator is 4. So in theory, one probability is 1 out of 4 times. Mark has 6 triangles and 4 circles in a bag. What is the probability of drawing 2 triangles without replacement? So what's the probability of drawing a triangle first? Well, there are 6 triangles and 10 different shapes. So that's the probability of the first one. Then I need to draw another triangle, but I don't put that last triangle back. That means I only have 5 triangles in the bag, and I also only have 9 shapes left in the bag. Now we can multiply these. I can simplify this. Simplifying before multiplying fractions is good. I can divide by 5 there. Here I can divide by 3, which makes this, I can divide this by 2, a 1 out of 3 chance. Alright, so probability is 1/3. Now what about drawing a triangle, then a circle without replacement? Well, the triangle is still 6 out of 10 for my first draw. And now I want to know what's the probability of drawing a circle without replacement. So there are 4 circles in the bag, but still only 9 shapes. So I can divide by 2 here as I cancel. And I can divide by 3 here. And I can divide, that's it. Alright, which gives me 4 out of 15. So it's actually more likely that I draw 2 triangles than if I draw a triangle and a circle. Alright, one more slide. Odds. Odds is a ratio expression expressing the likelihood of an event. So let's say we have a bag that contains 4 red marbles, 5 yellow marbles, and 1 green marble. Alright? If that's the case, the odds of drawing a red marble, alright, my first number, usually we write odds as kind of something like this, where M is the favorable outcome and N is the unfavorable outcome. So the odds of drawing a red marble, well, there are 4 red marbles, and the odds of not drawing a red marble is 6. So the odds of drawing a red marble would be 4 to 6. You could simplify that to be 2 to 3. The odds against drawing a blue marble, well, how many marbles are not blue? Actually, if you look at this, all of them are not blue. Alright? So that would be a very good chance of not drawing a blue marble. Make sure you pay attention to these. Alright? 10 to 0. Alright? You got a 100% chance of not drawing a blue marble. Alright, just thought I'd throw that out there. Let me know what questions you guys have, and I'm happy to answer those questions. Have a great evening.